Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, count pairs whose sum is equal to X. So we will be given two linked lists. Okay, we'll be given two linked lists, head one and head two with distinct elements. We want to determine the count of all distinct pairs from both the list whose sum is equal to given value X. For example, if X is 15, right? So what we want to do is we want to determine the count of all distinct pairs whose sum equals this, right? X. Okay. So here, if you see, what are there are total three pairs in this example. Okay. So what are the pairs? One is 4, 11, 4 and 11. Okay. So 4 and 11, then we have 3 and 12, right? 4, 11, we can say, then 3, 12, and the remaining one is 2 and 13, 2 and 13, 2 and 13. So we want to find the pair, we want to find pair A and B such that A should be from link list 1 and B should be from link list 2. Okay. So this is their ask is now. How can we solve this problem? Let's see the brute force approach first. Okay. So what we simply can do is we can have this, right? For example, let's write the pseudocode node T1 equal to head 1, right? So this head 1 is representing this linked list. Okay. So what we'll simply do is while T1 is not equal to null, right? This can be an outer loop. Okay. Now what we are going to do is we are going to have a T2, okay, which will be the iterator for this linked list 2. Okay, head 2. Now what we simply do is we will, for example, right, we'll have a count variable as well. That is count of number of pairs, right? So what we're simply going to do is while we'll have another while loop, right? T2 is not equal to null. Now what we'll do, we'll find out the pair here. We'll find out if, right? If T1 dot data plus T2 dot data equal to X. If such is the case, then that means we have found a pair, right? It's a simple, right? Simple use case. Okay. And then what you're going to do, T2 equal to T2 dot next. We're going to do, right? This is the end of the inner while loop, and the outer while loop will T1 equal to T1 dot next. This is the outer while loop. Simple. So here, this will solve a problem. Okay. This will give the count of number of pairs, but the time complexity here is O of n square. Okay. O of n square, because there are two while loops, right? There are two while loops, right? Now we want to optimize this. We want to optimize this, right? So we'll have to think of some better solution, right? Because the time complexity is O of n square. Okay. So before going to that better solution, I would request you to subscribe to my channel and like the video. Okay. So here the optimized one, right? So what we can do is we can push this, the linked list with all the data of linked list 1 into a set. Okay. A hash set, basically, into a hash set. Okay. Into hash set. And then what we can do is we will iterate, we'll go through this linked list 2, we'll iterate through this linked list 2, and we'll find the element, right? X minus whatever is the element, right? In linked list 2. X minus element of linked list 2 into this set, right? X minus. So if we find, for example, right? So what we are finding here is 15, right? 15 minus, we are finding 12. For example, let's take this example, 12. 15 minus 12, right? Which gives us 3. So 3 we must have already inserted in hash set, right? That means we have found a pair. Okay. So this would be the intuition behind solving the problem. Okay. Now let's go to the code. I'll show you quickly the Java code followed by C++ code. Before going to the code, I would request you to subscribe to my channel again. Okay. So hash set, let's write hash set, integer set equal to new. Yeah. Okay. Hash set. Then simply what we're going to do, as we have linked list here, right? Linked list here. So what we're going to do, we are going to have iterator here. Iterator integer, right? ITR1 equal to new, sorry, not new. So head 1, right? Head 1 dot iterator, right? And then what we're going to have here, while ITR1 dot has next. Then we are going to add simply set dot add. It will add the current element and it will take to the next element, pointer next, right? So this is it. That is, we have added all the elements of linked list 1. Now simply what we're going to do, we are going to have another iterator for head 2 for linked list 2, right? And similarly, we're going to do iterator 2 dot as next. We are going to have one count variable as well, in cnt equal to 0, right? If set dot contains x, right? Minus x minus iterator 2 dot next will do, right? Iterator 2 dot next will do. If it is the case, simply increment the count because we have found the pair, right? We have found the pair. and simply have to return count. Let me compile this. Okay, let me submit this. Yes, it is accepted. Let's quickly see the C++ code as well. So here it's simpler, right? Because we have the node, right? Actual linked list we have here. So yes, what we're doing is we are having this unordered set here. We're iterating to the list one, right? Inserting the data. Okay, moving ahead to the next element. And then simply what we're doing, we are iterating to the list two and finding whether x minus head two dot data, if it is there in set or not. If it is, then increment the count, increment this, update the head to pointer. Yes, and then return the count. Okay, so yes, so this is the solution. I hope you got the solution. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.